Hi everybody. Let's talk about molar mass a little bit. If you're in a chemistry class or some sort of science course, most likely you've heard of it. Let's deep dive a little bit into the types of problems that could be asked about it, and more specifically, what it is. So molar mass is given to you by this equation below, where big M is equal to little m divided by little n. Big M is your molar mass, usually given to you in grams per mole, or you need to find it in units of grams per mole. Little m is going to be mass in grams, and N is going to be the number of moles and given to you MOL for the abbreviation of moles. The most foreign concept is the idea of moles. So let's talk about what is a mole. Everybody knows that 1 dozen is equal to 12 donuts. So whenever we have a dozen donuts, we can count that there is going to be 12 donuts. A mole is another way of counting, but it's with this excessively large number, also known as Avogadro's number, which we'll talk about in a later video. So 1 mole of something is 6.022 times 10 to the 23rd particles. So if I had a mole of donuts, it would be way too many donuts. And I never thought I would ever say that about donuts. Just remember, a mole is just a unit of counting, especially dealing with particles that are very microscopic and very on a small length scale, so we can really count a lot of them. So molar mass is a combination of mass and the number of moles that you have in your compound. We're going to have a scale on the left to kind of emphasize what molar mass actually means. And on the right here, you have carbon that would be given to you on a periodic table. And this block here, and the most important part or information from this block for this lecture is that the bottom number right here. This is actually our molar mass, where there is 12.011 grams for every mole that you measure of carbon. So more specifically, if you put 1 mole of carbon atoms, or that amount of particles of carbon, onto a scale, what it will read is 12.011 grams. So let's get into some practice problems to kind of practice this molar mass equation and how we would end up using it for solving. So for this problem here, if a block of iron had a mass of 20.1 grams, how many moles of iron atoms are there? So here we have iron on a scale, and there's 20.1 grams of it. So let's count how many moles of iron that we actually have. So what we need is to go to the periodic table and look for the molar mass. And here it's going to be 55.845 grams for every mole of iron. So the calculation that you can end up doing is taking your mass, dividing by your molar mass, and you'll end up getting the number of moles of iron. If you have trouble rearranging equations, just rearrange your units so you end up with moles on top and moles of iron. If you take 20.1 divided by 55.845, you'll end up with this specific block is about 0.36 moles of iron. So a lot of particles of iron in that small block. And the second practice problem, a chemist weighs 2 moles of NaCl or table salt on a scale. What should the mass be? So now we counted out 2 moles of sodium chloride or table salt, and now we're trying to predict what the mass would end up being on our scale. So now we actually have 2 elements in this specific compound. So what we need to do is go to the periodic table and look at the molar mass for both sodium and chlorine. And since we have 1 sodium and 1 chlorine in every single molecule of sodium chloride or NaCl, what you're essentially going to do to find the molar mass of NaCl is just add them together. And when you add them together, the molar mass of NaCl is 58.44 grams for every mole of NaCl. So now, if you rearrange your units so you end up with grams on top with the information that you have found and were provided, 58.44 grams for every mole, times your 2 moles that you measured out, you should end up weighing around 106.88 grams of sodium chloride. Please check out my channel at The Science Equation and subscribe for more chemistry and math related content. And please like this video for more.